Welcome, everyone. Welcome to our first session here with Daniele, and we're going to be talking about the state of multi-tenancy. I think we've got a couple of slides. I mean, you mentioned there's a couple of slides to get through.
Only 212.
All right, awesome. So since we have a lot to get through, I'm going to go ahead and get started. And this is recorded. You can watch this on YouTube, LinkedIn, basically everywhere. So if you miss anything, go back and watch it. But got a lot to get through. So I'm going to go ahead and hand it over to Daniele. And I mean, unless you want me to do an intro, Daniele from LearnK8's Kubernetes Mastermind. I don't, I don't know what other stuff you want there, but all right, I'm going to drop out and hand it on over. So enjoy the content.
Thank you very much, Mike. Thank you. Thank you very much for joining. So yeah, let me just grab my slides. So my name is Daniele. Oh, you can call me Dan or Daniele, and Chris also makes fun of me and calls me D5E. I had the pleasure to present at KubeCon twice, and I'll be in London later this year to present a talk. I was one of the first 500 people to complete the CKA back in 2017. And what I do is basically just teach Kubernetes. So most of the time, I just teach Kubernetes at workshops, and I work for a company called Learn Kubernetes. And the plan for today is a little bit unusual, I guess. So I'm going to try and explain what kind of multi-tenancy models you can have in Kubernetes and what kind of tools are available in the market. And this is based on my experience looking at articles, projects, curating content for our network. Without further ado, let's start with the presentation. So before we tackle multi-tenancy, I think we need to take a step back and understand how Kubernetes works and what happens when you create a resource in Kubernetes. So generally, what you do is you go in the command line and you type kubectl apply -f deploy, and that request is then sent to the API server inside the control plane. And at that point in time, that what will happen is that request will pass through the API server, we will go through authorization, authentication, and a few more steps. And eventually, the object will be serialized and deployed inside etcd. Now, once it's inside etcd, then there is another component called the controller manager who will pick up the change. Notice that there is a deployment, that there is a missing replica set, and the replica set will see that there are missing pods, and then this will eventually create those pods and replica sets, and will register them inside etcd. As the pod are creating etcd, they also added to the queue for the scheduler. So the scheduler will be invoked, and the scheduler will basically look at all the available nodes and then find the appropriate nodes for these pods. Now, at the end of this process, not a single resource was created in the cluster. So all we have done basically is just writing values inside the database. What happens next is that we've got the kubelet, which is this component, this agent that lives inside the nodes of your cluster, which will basically go and fetch for informations from the control plane. So we'll go and ask for update. Is there any pods that has been assigned to my node? And if there is, then it's going to pull down the spec and it's going to try and run that pod on that node. So that's basically how generally, the request will go end to end in your Kubernetes cluster. Now, what happens when you have like several teams, several people, several users using this cluster? Then they will all try to apply kubectl apply -f deploy, and all this deployment will eventually reach the API server and etcd, where these deployments are stored. Now you can imagine the controller manager will go through a similar process of creating replica sets and pods, and then the kubelet at the same time will go through the same process. They don't really see these pods coming from different teams, not from different users. They will just go and pull down the specification and then just run these pods in the cluster. Now, most of what we're doing here is we are sharing. So if you have this cluster, then we're sharing this cluster with 4 people. We all share the same API server. We all share the same etcd, and then we all share the same nodes. And if you were to do something like kubectl get deployments, then you will get back a list of deployments, no matter from which team you're from. You will see all of them. Now, if you have kids, you might relate to this, but sometimes you don't want to share. right? I don't want to share. And one of the things we could do to not share is we could say, well, if this is an API server, what about we create like a way in the API to just create endpoints which are scoped to the team. So we could have /API/team and the rest, and /API/team B for and the rest, and so on and so forth. So each team is basically dedicated a scope inside the API. And what if we actually say, okay, this team is only allowed to use this particular path in the API, and so on and so forth? Then that could potentially help us sort of segregate things. So when I do kubectl get deployments, as team A, I'm able to see only my resources. That's basically, we just recreated namespaces and RBAC in Kubernetes. Namespaces, what they are, is just basically this scoped URL inside the API. And RBAC is basically a specification saying, hey, I've got this long API URL. If I break it down, what kind of part can be accessed? What kind of permissions do I have to access those resources? And that's basically most of the things that we do with namespaces. So namespaces are a way to control these API servers that we have inside Kubernetes. Now, if you want to know more about this, Salma had a very good talk last year that covered how our Kubernetes namespaces don't offer any isolation. And the video is on YouTube. So I'm going to post all the links later after the talk. Now, namespaces are great because they give us the ability to have these namespace resources, but we can do other things. And one of the things we can do is we can actually program these API server with more instructions. So imagine that all the requests going through the API, you are able to say, okay, I've got a request for a pod, but let's wait for a minute. Let's pause this. Let me check how many pods there are in the cluster. And let me aggregate all the values for requests and limits. And if the value for the request is greater than X, or if the value for the limit is greater than Y, then reject this request. Instead of storing in a database, just don't do anything. Just return back a 500 or any other error that you want. So this is basically, we just reinvented what we call resource quota in Kubernetes. So we're looking at these namespaces. Namespaces provides us with basically a scope in the URL for your API. And then on top of that, we can build quite a lot of things. We can do RBAC for permissions. We can do resource quota, limit ranges, and so on and so forth. So that's basically the power of namespaces in Kubernetes. And you want, most of the time when you're building platforms that are designed to run for multiple teams, you want all of these components to run together. You want all of these resources to do their own thing. You want resource quota to assign specific quota for your namespace, and you might want other things like limit ranges or network policies. Now, to combine all of these things together, I think there are tools which actually makes it a little bit easier to express these ideas in a single specification. And that, for example, is, you can see this CRD from Capsule. Then it's basically just breaking it, so basically encapsulating a lot of the things that you would expect from a namespace on a much higher level. And this is the first tool, perhaps, that we're exploring as we go through multi-tenancy. So tools that help us just get in namespaces, all of these different components that make the namespace a little bit more user-friendly and useful. Then we just package them together. So Capsule being one, there is another one called Hierarchical Namespace Controller. This one, there is a little bit of star. There is a star there because I haven't seen that much activity in the repo in a fair amount of time. And then there is KubeSphere, which is a little bit of a bigger project than just namespaces. But namespaces got some limitations. So the first one being not all resources, not all APIs in Kubernetes are namespaced. So persistent volumes, for example, are global objects inside the cluster, and nodes and even namespaces themselves are global object. So how can you namespace those? If I want to show only a certain type of persistent volumes to a team, how do I do that? Right? I don't have an easy way with RBAC because there is no granularity. It's all or nothing. And CRD is also are global resources. So for this, there is an interesting set of tools where we basically have a proxy in front of the API server, which impersonates the user and does some interesting filtering about what a user is allowed to see or not allowed to see. So for example, you could say, as an admin, you go in and you say, I want to see all the persistent volumes. You get all the persistent volumes in your cluster. But as a team, you only see the persistent volumes that are relevant to you. And the way it works is, I think it's a bit of a hack, but it works. These proxies are basically designed to look at the resource name. In this particular case, is looking for a resource which ends with team A, and it's basically just filtering on those. Okay, so the kind of tools that we see in this area, and sort of Capsule Proxy, which is an extension to Capsule, and then I think there is KCP, which is a little bit more than that, but I think it's worth mentioning anyway. And this Apple Workspace, which is a very interesting talk by James Munelli and Rato Zazzo from Apple, where they basically created a way to create the workspaces in Kubernetes. So this, by just abstracting this API service, so creating this API service as a service. But one of the interesting things that, if you watch the talk, it's worth your time. One of the things they say at the end of the talk is that, we're ready now to accept questions. And the first question was, does it work with CRDs? Short answer, it does not. It does not. And why it doesn't work with CRDs? Because CRDs are very tricky, because you basically, let's imagine that you want to have a CRD with two versions, because maybe you have, let's say, the API gateway CRDs, and you want to install one version and another just to test, what's the difference between two versions. Now, unfortunately, this is not possible because we are sharing the database, right? So all of these CRDs, CRDs are very difficult to isolate. I'm going to see how we're going to fix that. The other things that we're isolating is nodes. And this could be problematic because, yes, we can limit CPU and memory. We can find ways to isolate network, but it's very difficult it's not possible at the moment to isolate IOs. So if you have a database, for example, and other nosy neighbors in the same node, they will compete for IOs. And then the network bandwidth as well. That's something that we can isolate in the nodes. So you will face issues if you use namespaces with this kind of workload. So what happens if you have CRDs, right, and you want to isolate these CRDs? Then the other option you have is to basically, because the problem that we have is that we managed to isolate the API server, but the problem was the database. So how do we actually isolate that database? And the idea here is that instead of isolating the database, we just isolate the control plane, right? So instead of having like a single control plane, then we have a dedicated control plane for each user in the cluster, for each team. And each one gets his own API server, so we get all the benefit from isolating the API server. And then each team gets a dedicated database as well, so a dedicated HCD as well. And the beauty of this is that each one of them could be a different versions of CRDs, for example, and this will still work because the databases are isolated. Now, how do we do this? There are basically three big strategies. There are three main strategies when talking about isolating control plane. The easiest one, and it's also the most difficult to implement, is to have separate clusters. So you could assign a separate cluster to each member of your team. The other option you've got, which is quite interesting, is you've got like several control planes. They all live inside a manager cluster, and then people will bring their nodes and attach to those control planes. And the last one is basically you have a single cluster, but you nest these control planes in the cluster and reuse the nodes. So we're going to see each one of them and how they compare. So we can just look at the different methodology and what kind of trade-offs they make to implement multi-tenancy in Kubernetes. So the first one is a separate cluster. I think this is the easier one to sort of visualize, because what we do is basically we assign a cluster to each team. And in the way we manage these clusters, we basically find most of the time, most of the tools, they use another cluster, which is going to push changes to all of the clusters, and each team can individually deploy applications to their own. And the secret sauce here is to find a way to build this manager cluster in such a way that things can be distributed. So deployment, networking, so storage is a way to basically distribute and find ways to connect all of them together. Now, some interesting tool, I mean, this is very fuzzy, but some interesting tool in these areas are Admiralty, Karmada, Sveltus, KubeSphere, and KubeSlice. So I think these tools are trying to solve the problem of, okay, I've got several clusters. How do I make sure I sort of create and distribute the workloads, or find a way to connect them together? Now, just give you an example of what is the intent. What do they do, these kind of tools? So Karmada is, in the cluster manager, what you will do, you will install the control plane for Karmada, and then each cluster will get an additional agent, which is going to connect to the API server of that control plane and just dispatch the commands, right? So you do a kubectl, it will go through the control manager for the Karmada controller, which will dispatch to all the other clusters as well. Now, let's have a look at another one. So we discussed dedicated clusters, but the other one, which I think we're going to look at next, is basically having a control plane, but inside the control plane, we basically spin up other control planes as pods. So we discussed how the control plane is a combination of API server, etcd, controller manager, and scheduler. So we're basically packaging all of those as a pod, and we are deploying that into a cluster. Now, the control plane doesn't do anything unless it has some nodes where we can deploy the workloads. So what we do next is we connect nodes to this control plane inside another cluster. And what we do here, we see a very good demarcation. So we've got a cluster manager, which is running only control planes. So all of the pods inside the cluster are control planes. And then we have the fleet of worker nodes. And these worker nodes are basically attached only to the relevant control planes. And I think this is basically what you get when you provision a cluster from AWS or GK or Google Cloud or Azure. What they do is basically they provide you the control plane, and then they attach the worker node. So essentially, these tools are helping you build a managed service. Now, how do they work? So generally, you have a single cluster, and then you attach some nodes. Now, this is usually called bring your own nodes, and basically what you do is you provision your own virtual machines, your own nodes, and then you attach them to this control plane. And I think this is really important because this is basically shifting a lot of responsibility for managing and maintaining and attaching these nodes to the team who wants to use the cluster, just like a managed service. And then all of these control plane upgrades is managed generally by whoever is providing the service, and you get Queues isolation because you've got a dedicated control plane for each team. Now, tools in this space, Kamaji, HyperShift from Red Hat. I think vCluster Pro can do this, and then there is Cosmotron from Mirantis. Let's have a look in a little bit more in depth how it works. So basically, you have this management control plane. You just create a pod, and that pod is a control plane. Then you provision your own virtual machines. You install the kubelet, and then you connect that kubelet to the control plane. At that point, you have a cluster, and then from that point onwards, you can create workloads. See, if another team wants to create a cluster, they first have to create a control plane, then they have to provision the nodes, then they have to attach it, and then they can deploy their workloads. What I want to stress is that this kind of design works well if you have if you're providing a managed service. And if something breaks in a node, whose responsibility is that? Generally, the team who's attaching the nodes, right? It's just like if something breaks, you don't go to Azure, you have to fix it. Probably you have to fix it yourself. Cool. The other option that you've got is what if, instead of having these control planes outside in different cluster, then we just keep everything in the same cluster. We just don't create extra cluster for managing pods. And that's basically the idea. And the idea is that, well, what do we do with these control planes that don't have nodes? What can we do? And the idea is that we sync the resources back to the main cluster. And we have a single cluster, which is good. There is some syncing, and this syncing can be done in several ways. We're going to see in a second how. It is fairly easy to upgrade the control plane, as they are just pods inside a cluster, similar to what we saw with the previous methodology. And you have some isolation as well. So this database and API server is isolated, still isolated, because it runs inside a pod. Now, there are two tools in this space. One is vCluster, and the one is K3K, with K3K being a new entry. And currently, if you go on their project page, they will also say that it's experimental. And that's because they use a very different strategy from vCluster. We use a visual kubelet to do the syncing, which is slightly different from what vCluster does. So let me show you what vCluster does. So vCluster will basically create a control plane as a regular pod, but that control plane has no node, right? So if you create a pod, that pod is stuck. It doesn't go anywhere because the database is the wrong database. So instead of what vCluster will do, will basically just look inside the database and do a copy of that pod from the nested control plane to the main control plane. And then the main control plane will just schedule it as normal, and the pod will be created inside inside the main cluster. So this is basically the secret sauce for vCluster. So they got this syncer, which will basically just move the resources from one to the other. And then this works similarly for global resources like persistent volume. So the persistent volume will be seen only by the user that owns that particular control plane, and the body will be synced behind the scenes by vCluster. Now, we touched on 5 or 6 different ways you can do multi-tenancy in Kubernetes. We touched on namespaces. Then we had a look at these Namespace-as-a-Service, where we have like several components like quotas and limit ranges all packaged into one. So these were a few tools that we explored. And then we had a look at wrapping the API, so we can basically filter what goes through the API with a proxy, and we can do some interesting logic with that. In this space, we basically have Capsule proxy. So Capsule basically covers both of the areas for Namespace as a service and Kubernetes API as a service, and then KCP. And then when we move through a little bit to the right in the spectrum, then we find these control plane as a service, but the control plane is deployed as part of the cluster. So we're still managing a single cluster here. And here we have vCluster and K3K. Then as we move up, then we have control plane as a service. So control plane as a service, there you have an external clusters, and then we have our own nodes, and we just attach them. And in this area, we basically have HyperShift, Cosmotron, Kamaji. And then the last one, as you saw, was like the easiest to think about, but perhaps the most complex to implement, and that's basically dedicated cluster and ways to basically stitch them together. Now, you look at this chart, you look at this graph, and you say, okay, that sounds fair. Just a fair representation of how multi-tenancy works in Kubernetes. But I don't think it's fair. I don't think it's fair at all. I think the way, when I built this, when I started poking around and sort of thinking about how these things fit together, I sort of also asked myself, but how likely are these tools to be used, and what kind of things they're trying to solve? I think all of the tools that are working on dedicated clusters, I think, are generally useful if you're really into things such as multi-cloud and multi-region. So if, for example, you have like a business where you have several clusters in several geography, then I think this will work really well. But I think their cases are not for everyone, right? Not everyone is doing multi-region or multi-cloud. So I think, I will shrink the use cases to a bit. I would just push them. And then the other one which I looked at was control plane as a service. And I looked at, I think that the people at Classic are quite transparent about where their software is deployed. And I looked at what they shared. And, as I looked through their post, I basically realized that most of the time, when you want to create a control plane as a service, what you're doing is you're basically creating a managed service. So most of the announcement that they did for this kind of product is around, services creating their own managed service. So they use Kamaji to provide that kind of flexibility. And I think unless you're a managed service, I think this is basically it. You basically need to be a managed service to get the best benefit from this kind of tooling. So I think the use case for this, I think, is very, very narrow, which leads me to the rest of the pack, which is basically Capsule, vCluster, are basically covering most and Kubernetes namespaces, just vanilla Kubernetes namespaces. I think just looking at the kind of content created by the community, so I went back and just looked at what kind of content is shared and created on our network. Then I realized that they tend to pop up quite frequently. As in, I think the community is basically just using simpler tools because not everyone is basically creating a managed service or doing multi-cloud. As simple as that. Now, the other things which I think is worth discussing, and I promise I'm almost done, is complexity. I think when you're using Kubernetes namespaces, the complexities that you're having is basically just managing these namespaces. So you're fairly close to what Kubernetes already provides. So when you install things like capsules, which are wrapping and making it more usable, to combine several things together, you're adding a little bit of complexity, but at the expenses of getting some nicer way to sort of manage all of it. So I think complexity-wise is, you're still trading that complexity because, of course, you're introducing a new tool that could break. You have to manage. You have to monitor. But overall, it's fine. And then there is another step which you get is when you basically go and do control plane, either nested or external, and you have to deal with the fact that there is some syncing in the case of vCluster and K3K, and that could add on complexity on when things break, where do I look at? Of course, there is some element of, okay, I'm trading this for simplicity, so I can create a nested cluster very, very easily. But overall, it's not, something breaks. So the experience is very nice. It's like a namespace, but something breaks. So debugging might be a little bit more complex than a vanilla namespace. And then, of course, there is like dedicated namespaces, dedicated the clusters, which are quite tricky to explore. So I would say that most of the time, so the first area is mostly just Kubernetes namespaces. So Capsule is adding some sprinkles on top. So I think this is where you get like the most closer experience to what Kubernetes provides. Then we've got some, as soon as we move up, then we start having some benefit like isolation of CRDs, but at the expense of some more trickery to make this work. And then at the end of the scale, we basically have like this, because these tools, they don't provide anything. They provide only blocks that you need to put together. You end up with custom solutions most of the time. So you might use Karmada, it's just providing you a way to manage workloads, but how do you solve networking? How do you solve net storage? So you end up building your own platform with your own things, which is a custom snowflake. And usually you need a large team to fix that. So how should you fix it? So how do you, we talked about several tools. We still talked about several methodologies. So how should you choose those? And I think, of course, there is no like a straight answer. There is no like, okay, this is a tool. Just go and do it. Just go and use that. I think generally, I think you're looking at three scales. There are three slides you can move around and play with. So the first one is isolation. So what kind of workloads am I deploying? And what kind of isolation do I need? Do I need the same isolation for dev and same isolation for prod? Or can I be a little bit more flexible in isolation for dev, for example? Can I just use namespaces there? The other one is ease of management. So you need to maintain this. I'm happy to use sync if something breaks, how do I fix it? And the other one is cost efficiency. So, of course, creating namespaces is not the same as creating a dedicated cluster, right? So there are some costs involved in these choices. So generally, at least the way I look at this problem is I basically have like the 3 different options, which are, I've got a single cluster, I've got a manager cluster, which is going to either deploy, which is going to basically host the control planes, and I've got dedicated clusters. And then each one of these options comes with some additional add-ons. So for example, if I choose a single cluster, maybe I can have dedicated node pools, or maybe have a sandbox runtime to increase my security level. And then on those, I can also have different options when it comes to, okay, should I use a single monitoring solution for all of my tenants, or should I have dedicated solutions for each one of them, right? And sometimes it's a matter of actually combining these things together to get the right balance of flexibility and costs and isolation and ease of management to get what you want. Cool. So I talked quite a lot, and I just want to share sort of what am I thinking around these multi-tenancies in Kubernetes. So I think overall, Kubernetes is designed for sharing. So if you look at how Kubernetes is structured and how it's been coded, so the overall idea is that we've got a very large number of machines and compute unit, and then we're just sharing those. So it's not really built for hard multi-tenancy. It's more like a soft multi-tenancy. Now, we have ways to isolate things in Kubernetes. We go from simple things like namespaces, which are just isolating the API, to more complex things such as nested control planes, external control planes, and then dedicated control planes. Those are sort of the options that we end up. Of course, all of these options come with trade-offs, right? So, and these trade-offs usually comes in different forms. So we talk about isolation, costs, and complexity. So we're basically just trading. It's not like is the best tool in multi-tenancy. I think you're just making a trade-off. And it always comes down to what you're doing. So if you're doing something simple, maybe you can just keep and do namespaces. And then maybe if namespaces are not enough, you can level up and maybe do use something like Capsule, for example. If CRDs are something that you really want to use and you want different versions, then you need to step up again and maybe use something like a control plane as a service tool. Yeah, I think that's basically all I wanted to share with you today. I just want to thank you for joining me. I want to thank Loft for having me. And yeah, I just want to close by saying that some of the things I understand that some of the things I showed you is quite theoretical, but Sam is going to take it very, very practical next week, same time, same place, and he's going to show you how this stuff works.
It was great. I appreciate it. Yeah, that was an awesome presentation. Thank you so much. We didn't have any questions. I think everybody was just too in awe of like what you were presenting. But if you have any questions, go ahead and add them. I'm going to bring up our information about like next week too. We'll give it a minute or two and see if there's any questions. I mean, we got some comments. Carlos, I'll add that there. Carlos saying, the days of dedicated node pools are in the past with Carpenter, and some other good comments. But no questions yet. Let's see. Let me see. Everyone's saying thanks. They really enjoyed the presentation. Yeah. So yeah, if you missed anything in this presentation, head to our YouTube channel. There's going to be a recording there. There's also a recording on LinkedIn, and then we're new to the StreamYard webinar stuff, but you might be able to actually access it there too. So I had a question if you could share the PDF. I don't know if you've got the slides somewhere, or if this is a presentation you have out, or they can just watch the video.
I think we are planning to put a blog post together as well, so you can sort of get this in a written form. I know some people prefer that to videos, and
yeah, we should have a recap of all this stuff coming up.
Yeah, definitely the video, and I've got a bunch of links. I don't know how to share them, Mike.
Share them. So okay. So I'll do the slides on this and say where you can go. I think we're going to share them on the Loft users Slack. So we'll put them in the vCluster channel there. We can share a bunch of stuff there. So Yeah, so let me plug the stuff real quick here at the end. So yeah, next week, same time, same place, we're gonna have a workshop with Siam, and we're gonna see how this stuff actually works in action. And then if you want to see more information about the slides and all that, just join our Slack community, and we'll post in the vCluster channel. We'll post information about Multi-tenancy March and some of the other stuff coming up too. If you want a demo, vCluster.com, enterprise demo. But yeah, join the Slack community. I'll leave this up for a minute. It's just slack.vcluster.com. Join in there, go to the vCluster channel, and then we'll post a bunch of stuff in there. And then, like I said, go to our YouTube channel. But I'll leave this up for a minute in case people need to see it. But no questions yet. Let me check the chat. Right, like just people saying, it was amazing and thank you so much, and they're looking forward to the workshop next week. But always a pleasure to have you present. Do you have anything else you want to? Anything else you want to say? I know it's late.
There is a question which I think it is quite interesting. And so, what about network isolation in Kubernetes? Something related to tenants VXLANs. So I think this is a very hard question, which maybe I shouldn't be taking, but I'll try it anyway. So I think when it comes to, if I look back at Kubernetes, then there's always these. Okay, we try to share as much as we can, and the overall idea is that your tenants are people you can trust. Probably your colleague next door. You can go and walk to them and shake their hands. So I think when it comes to isolation of network, then we try to segment networks so things don't go from one pod to another. Now, of course, you can use network policies for that, and there are interesting case studies from a company in UK called Monzo, which is a digital bank, and how they manage network policies at scale with thousands of microservices. But I think overall, yes, I think the other option would be something like service meshes, which of course they operate on a much higher level. So we're talking about L7. But I think when it comes to multi-tenancy, I think it really depends on what is the intent for segmenting the network. So I think sometimes I see financial institution having, being regulated and say, okay, I need to separate those because of regulation. And I think it's possible, but you need to understand. I think you need to understand how these network policies work and what kind of trade-offs you have in place, because sometimes the trade-offs are not enough. And you need to go and basically use dedicated cluster to make sure that this network are dedicated. Now, of course, you could go and do more complex stuff like playing with CNIs. But I think, again, if you take this back and we look at the fundamentals of Kubernetes, then the first rule of Kubernetes networking is any pod can talk to any pod. And then on top of that, we add network policies to basically filter to other firewall, which is programmable. So I think overall, I think it is a complex subject, and it really comes down to what are you trying to achieve by segregating these networks.
I think that would be like OpenStack or something. Just think about VXLANs with tenants, it's like an OpenStack thing.
Answer.
All right, well, awesome. Let me go ahead and show it one more time, slack.vcluster.com, and then thank you, everyone. Oh. All right, so they're going to explain the possible use case. Let's see. Kubernetes with Kubevirt VMs as nodes. At this level, the tenants should be hard segmented with VXLANs. Yeah. I'm trying to think. So K8s and K8s and VMs. So you're running virtual machines, and you're building a couple of virtual machines running on Kubernetes, and then you're doing Kubernetes in those virtual machines. But it's still going to be using the underlying network.
It's very specific.
Yeah, very specific.
But I think at the same time is, if I'll admit I'm a little bit ignorant on Kubevirt, but if I look at how Kubevirt works, it's basically just trying to run these virtual machines as pods.
Yeah.
So my thinking is, in Kubernetes, every pod can talk to any pod. So if Kubevirt is launching a virtual machine as a pod, then maybe that is going to be okay. I can figure out, I can use a network policy to prevent traffic going from one to the other, but I still back the same problem. I don't know. I would need to.
We're still relying on the same network interface or the same network implementation underneath, right? Like, and it depends on what you're running and if you can assign even the VXLAN to that, right? Like, it's just libvirt in a pod.
Yeah, I'll just say to save myself from I would say if you reach me out on LinkedIn, I will try to answer this. I think on the top of my head, I think this one should just fall back. I don't know. That's my.
We get a question. It's one of the most complicated questions. It's a very hard to implement. Yeah, if you figure it out easily how to set that up too, I'm sure there's a bunch of like telecoms that would be interested in talking to you. Right? Like, well, I think that's about it. I think that's all we have. Like I said, join us next week. We'll do a workshop, and then we've got a bunch of these events going. If you go to our YouTube channel, you see we've got the next 5 weeks after this of events. So definitely check out the next ones. And thank you so much again, Daniela. You got anything else you want to say before we head out?
Thank you very much. Yeah, thank you very much for joining.
Awesome. All right, everybody. See you next week. Can't wait. All right, bye.
Bye.